Hello, this is Scott Dahman, Director of Business Development at PowerWorld Corporation. This session provides a little bit of background on PowerWorld Corporation and also an introduction to using PowerWorld Simulator to build and edit PowerFlow cases. The goals of this and all of our training sessions are basically to give you an overview of how PowerWorld Simulator works and give you a better understanding on how to use it for system analysis and visualization. The primary goal here is just to make sure that you are aware of all the capabilities available within Simulator. It's really impossible to cover everything in these training sessions, but we want to make you aware of them, and then if you've got more specific questions, then you can ask us. PowerWorld Simulator was designed originally with user friendliness in mind, and visualization was a key motivator as well. It integrates a lot of commonly used analysis tasks into one single program and one interface, and it runs on the Microsoft Windows platform. The history of the company began in 1994 when Tom Overby, a professor at the University of Illinois, started to build some software to use as a teaching aid basically to students and also to non-technical audiences. And he was in the early days of PowerWorld Corporation. He collaborated with a couple other professors at the University of Illinois as well. In 1996, PowerWorld Corporation was formed to further develop and commercialize the simulator tool. With Simulator 13, the software has become extremely advanced in terms of the features and the capabilities that are built into it, but it maintains its roots as a powerful visualization engine, and also with an emphasis on a good user interface that's easy to use. Next, we'll talk about using PowerWorld Simulator to edit and build PowerFlow cases. The PowerWorld Simulator integrates two functions that at one time were commonly separated in PowerFlow simulation software. There's a graphical Power System case editor, which can be used to build and edit cases, and then also the analysis tools, which again are integrated into a single user interface. Beginning with Simulator 13, the menus and the toolbars that used to be in Simulator have been replaced with the ribbon interface and the application menu button located in the upper left part of the Simulator window. If I switch over to Simulator right now, when I have no case, I basically have to click this application button here in the upper left, and I can choose from a couple different options, like opening or creating a new case or opening an existing case. And for this exercise, we will create a new case. And it automatically opens a window, a blank one-line diagram, to which I can basically add objects to build the PowerFlow case. The old menus and toolbars are integrated into the new ribbon interface, which is based on the Microsoft Office Vista Fluent user interface. The idea here is to combine and simplify the toolbars and the menus such that when you click on a menu item or a ribbon tab, you see only a set of toolbar buttons which are sensitive to the context of that ribbon tab. There is the application button, as we mentioned before, that's always in the upper left hand corner. And there's also a quick access toolbar, which is a permanent list of commonly used commands to which you can add certain commands that you use frequently as well. And it's always visible regardless of which ribbon tab you're on. Within each ribbon tab then there's also a different sets of ribbon groups. Like for example in the case information that we see here, we have the case information group, the case data group, the views group. The help button is also always visible in the upper right hand portion of the screen. So when you select a different item from the ribbon tab, then you see a different set of task-specific buttons related to that ribbon tab. For example, this slide shows the Tool tab and related tasks for tools. And I'm going to go ahead and switch over to PowerWorld Simulator to demonstrate some of these other features. You can add commonly used buttons to the Quick Access toolbar by simply right-clicking on one. For example, if I wanted to add the area zone filters to my Quick Access toolbar, I could simply right-click on it and then add it to the Quick Access toolbar. If there's anything up here that you wish to take down, you can also right-click on it and remove it. A lot of these buttons also will allow you to float the mouse over them, and it will give you a hint basically describing what action that button does. The case editor and the PowerFlow analysis package in Simulator are implemented in two modes, the edit mode and the run mode. The edit mode is used to add or edit objects in the PowerFlow case. Basically, anytime you change the topology of the system, for example adding buses or adding transmission lines, you must be in the edit mode to do this. And the run mode is basically where the analysis is performed, solving the PowerFlow and performing some of the advanced analysis, which we'll talk about later. So in the edit mode, you can create a new PowerFlow case or modify existing cases, and you can do this either graphically or through text displays. In run mode, you can perform a PowerFlow solution by itself, and then there's all these additional add-on tools that can be applied to a solved PowerFlow case, such as contingency analysis, time step simulation, which allows you to vary certain parameters from hour to hour, for example, to simulate the system over time. The optimal power flow, which allows you to dispatch generation according to an objective function, such as a least cost dispatch, subject to transmission constraints. And with it, you can also determine things like locational marginal prices and the cost of operating the system and other economic variables. The PV and the QV curve tools allow you to determine static voltage stability margins. For example, how much power can you transfer between a buyer and a seller before the power system won't solve and the voltage will collapse. The QV curve allows you to determine the reactive power margin that's available at certain buses in the system. So how much additional reactive power load could you put at a certain place in the system before you would cause a voltage collapse. The available transfer capability, or ATC tool, allows you to determine how much power can be transferred between a buyer and a seller subject to thermal transmission constraints. So basically line limits, interface limits, and so forth. The security constrained optimal power flow combines the optimal power flow tool with the contingency analysis such that you can seek a least cost dispatch that will keep the system secure, in other words, meet all the transmission constraints in the base case, and then also meet them during a set of predefined contingencies. There are also a lot of sensitivity analysis tools, a group of related tools, and loss analysis and fault analysis can also be performed. So back to edit mode. We can use the edit mode to create a new case or modify an existing case. And in this example, we will build a case in edit mode using several different methods. You can also switch to edit mode anytime during a simulation if you need to change topology, add buses, add generators, and so on. So to create a new case, basically what we already did is we went to the application button and we selected the new case, and that's how we got here. So when you create a new case, you're automatically put in edit mode, and if you have any existing cases in memory, it'll prompt you to ask if you want to save them. And the the blank one-line diagram is also presented in a default one-line background color. In this case, it's white. And the case may be built by graphically drawing objects on the blank one-line diagram. So the first thing that we'll do is we will enter a bus on the one-line diagram. And to do that, if I switch back to Simulator, if I click my Draw Ribbon tab, I can see there are different things that I can insert. For example, if I click the Network tab, I can see I can insert buses, generators, loads, shunts, etc. Of course, the first thing that we need to add to the power system is a bus if we don't have any buses in the system. Then we can begin to add some of the other things. So I'll click the bus, and then down in the one-line diagram, I can place it anywhere I like just by clicking one time where I want to position it. It brings up the bus dialog, which asks you to fill in the bus number, the bus name, and some other basic data about the bus. I'm just going to call the bus Bus 1, and I'll leave the nominal voltage at 138 kV, but if you'd like to change that, you can change that as well. Also, every bus needs to belong to an area and a zone, and it also has to have an owner. Substation information is optional. We'll talk a little bit more about substations later. But for now, I'm just going to select all these, leave all these defaults as they are. Down here, we can also change the orientation, how it's drawn on the one-line diagram, and then also we can change the shape and do some other things as well. When I'm ready to insert it, I'll just click OK, and then the bus appears on the one-line diagram. Another thing that we have to do in each power flow case is make sure that we have a system slack bus. And I'll need to go back into the information for this bus to designate it as a system slack bus. If you just right click on the bus in the one-line diagram, you can bring up this local menu here, and the first option is the bus information dialog. Go ahead and click that. It'll bring up this dialog, and then on the first tab down here in the lower section on the bus information, we can designate this as a system slack bus. That's just basically a mathematical construct to ensure that the power balance equations will be satisfied. And every case, every actual electrical island within a case must have a slack bus identified. So click OK to close that. And if I switch back to the slides, on slide 19 here, it shows some screenshots of that bus options dialog, and explains too that each electrical island needs to have the slack bus, and that can be designated again on the bus information tab. So the next thing we do is we'll add a generator to the case, and the slack bus does need to have at least one generator. So we will enter that on the slack bus in Simulator. So again, I can go, staying in my draw menu here, if I click on the Network tab and then click on the generator, I can insert a generator simply by clicking once on the bus that I want to add the generator onto. So I'll click on bus 1, and it will bring up this dialog. And the tab that it puts me in to begin with is this power and voltage control tab. And I do need to specify several things on this tab. I have to give it an initial megawatt output. I'll give it an output of 50 megawatts. And I'm going to leave most of these other defaults as they are. It'll be available for automatic generation control, which actually is required for the slack bus. I'll tell it that I do want to enforce its limits. I can give it limits, let's say between 0 and 200 megawatts. I can just tab from field to field and then type in the numerical fields. I'm going to accept the rest of the defaults on this tab And one other thing I want to check is if I click the display information, there's an option to have the bus anchored. And basically what that means is it will be anchored to its bus. The generator rather will be anchored to its bus, so that if I move the bus around on the one line diagram, the generator will move with it. And I'll go ahead and leave that checked and then click OK. Okay, at this point I'm going to save my PowerFlow case, and to do that I can go up to the application button, click it, and then choose the Save Case option. And I'm going to just go ahead and call this, give it a file name called Simple Case, and click Save. And what it will do is it will save the actual case information into a binary file with the extension PWB for PowerWorld binary. It's also going to ask me for a name to store the one-line display file, or the PWD file. I'm just going to leave it with the same name, Simple Case, and click Save. And then once I've done that, I can see in the status bar the name of the case is shown up here, as well as the name of the one line being shown on the one line menu. Or I'm sorry, at the top of the one line toolbar. And to see what the program has done to this point, I can also turn on the message log, which can be accessed from this quick access toolbar, about the fourth one from the left. If I float the mouse over, I can see the word log. And if I click it, it shows me that it saved the case and the one-line file as well. And it's sometimes a good idea just to check the message log to make sure that there aren't any errors while you're running simulator or while you're trying to save files. So switching back to the slides and skipping ahead to slide 24, we can see that the PowerFlow case is again saved in a binary format called the PWB, and the one line is saved into a PowerWorld display format, or PWD. Basically, keeping these two separate files allows you the flexibility to use multiple one lines with a single case, or to reuse a single one line with multiple PowerFlow cases. So we'll switch back to simulator and then add a couple more objects, like a second bus, a load, and a transmission line. So I'm going to move my log off to the side here. And again, going back to the Draw tab and clicking on the network drop down, I can again select bus and then click in the one line diagram where I'd like to place the bus. And I'm going to accept the default number of 2, and I'll give it a name of 2 spelled out, and otherwise keep the defaults and click OK. The next thing I want to do is attach a load to bus 2. So again, I'll click the network drop down and find load in that list, and then just click once on bus 2 to add the load to bus 2. And on this load information tab that comes up, I want to give it a megawatt value of 200 megawatts and a megavar value of 100, both in the constant power column. You can also specify loads as having a constant current component or a constant impedance component, or any combination of the three. I'm just going to accept all the other defaults shown on here and then click OK. If I want to reposition objects that I've added to the one line, I can simply click on them with the mouse. Just left click and hold down the mouse button, and then drag the mouse with the left button held down. In doing so, you can reposition buses on the one line diagram, and any objects that are anchored to the bus will move with the bus. I can also click and drag in an empty portion of the background on the one line, and when I do that, I'm basically panning across the entire one line, or I'm moving the view in the one line. I'm not actually moving individual objects though. These techniques are also described in the slides as well. In addition, there are some keyboard shortcuts that you can use to move objects around on the one line that are shown here. And you can also pan in the one line diagram by using the arrow keys and by using some of the page up and page down and a couple combinations. You can change the step size basically with the pan. Zooming can be done a couple different ways as well. There's a zoom ribbon group on the one lines ribbon tab. If I click on one lines up here, it'll bring several different options, and one of them is this zoom group as well. And if I float the mouse over some of these buttons, I can see what they do. For example, I can zoom in on an area. If I select that option by clicking on it and then move down to my one line diagram, I can click and then drag around a rectangle, and then when I release the mouse button, it will zoom in on that area. I can also change the zoom to a certain percentage through the drop down or by typing a number in. Another helpful option is this show full one line button, and if I click that, it'll basically zoom to the extents of the objects that I have on my one line. There are also some keyboard shortcuts that you can use as shown on this slide. And then also in the simulator options dialog one line page, you can elect to use mouse wheel zooming. Switching back over to simulator, again on the one lines tab, I can select these one line display options. And it opens a dialog with several different pages. This display options page has a checkbox right here for enabling mouse wheel zooming. And then if it's enabled, you can just spin the mouse wheel to zoom in and zoom out. You can also undo certain actions on the one line diagram. From the draw menu, you can select an undo, and basically it will affect edits to the one line diagram. It won't affect changes that you've actually made to the PowerFlow case, and it doesn't work with things that you might type into the case information displays, which we will look at later. But for example, if I perform an action like moving this bus and I decide I didn't really want to do that, I can click on my draw ribbon, and then over here on the right in the clipboard ribbon group, I can select undo the one line move / formatting, and it will undo that action. The undo feature uses some system memory, which you can also alter in the PowerWorld Simulator Options menu, which we just looked at. If you open that back up and you select the environment option, then you can specify how much memory is allocated to the undo. The one-line editor also has an invisible drawing grid, which basically helps you align objects, and when you're moving objects or placing objects on the one-line diagram, by default they snap to the grid. You can also temporarily disable it by holding down the Alt key while you are dragging an object. But if I switch back over to Simulator and I try to move an object like this bus right here, I can see that as I'm moving it, it jumps in discrete steps like this. If I hold down the Alt key, I can move it with a little bit finer precision because I'm temporarily disabling the snap to grid. If I go back to my One Lines ribbon tab and select the one line display options, I can change some of the parameters for the grid as well. So then I have to select the page for the grid / highlight unlinked objects, and I can see right here that I've elected to snap to the grid. I can change the spacing. By default it's 1. I could change it, the X and the Y spacing, to a different number. And then I can also elect to show grid lines in the background on the one line if I would like as well. If I go ahead and do that, then we'll see what that looks like. You can see the grid, and as I'm moving objects on the grid, you can see how it snaps to the grid as well. So the next thing I'm going to do to the case is add a transmission line. And first I'm actually going to go back in and change my grid options. And I'm going to change the spacing back to 1 here and just tell it to hide the grid and click OK. So to add the transmission line, I'll go back to the Draw menu, and I'm also going to get the log out of my way here so it's a little bit easier to see what's going on. And again, I'll go back to the Network drop down list, and I'm going to select the transmission line option. Now to draw the transmission line, to begin, you first select one of the terminal buses that you'd like to draw the line between, and then just click once. And then you can also make subsequent clicks to route the transmission line on the one line diagram. It is not recommended that you click and drag the mouse while you're drawing a transmission line, because doing so will basically give it a whole bunch of vertices while you're dragging the mouse and moving it. And usually that's undesirable. It leads to a pretty unclean look and so forth. When you get to the terminal, the other terminal bus after you've routed the line where you want to finish drawing the transmission line, you simply double click on that bus in order to finish drawing the line and then bring up the transmission line options dialog. After creating the transmission line, I have to give it some parameters. Like, for example, the impedance parameters, I can enter those just by selecting the field that I want to enter, and I can just type it in. So for the series resistance, let's put in 0.02 per unit. And then I can use the tab keys to move from one to the next. And I'll put in 0.08 for the series reactance, and 0.1 for the shunt charging, or the B value, and I'm going to leave the shunt conductance to 0, and then I'm also going to give it a limit of 400 MVA, and you can leave these other limits blank for right now. Then when I'm done, I can click OK, and it will insert the transmission line. Once I've added the transmission line to the diagram, you can see that it inserts a number of handles over the vertices when the transmission line is selected. If I want, I can float the mouse over one of those vertices and then click and drag to relocate it. I can also add additional vertices to the transmission line after I've added it by holding down the Control key and clicking at a point along the transmission line where there is no vertice. And I can reposition that as well. If I have extra vertices that I later want to remove, I can hold the Control key down and click on an existing vertice and it will remove it. The slides also provide a good summary of this functionality for the line routing. I can also add other objects to transmission lines and transformers, such as circuit breakers. Now, the circuit breakers in PowerWorld Simulator generally are not true breaker representations unless you've got every single node in the power system modeled with a separate bus. Generally, in planning power flow cases, you'll get a bus branch model which consolidates a lot of the true breakers into single buses, basically. But generally, the circuit breaker in PowerWorld Simulator is just used as a construct to let the user know whether the transmission line is open or closed. The location of the circuit breaker that you put on the line in PowerWorld Simulator generally doesn't matter. When you automatically insert a line, typically it will put one at either end. And again, it's just for convenience for the user to be able to open or close the line when interacting with the one-line diagram. You could add additional circuit breakers to the transmission line if you want by going to the Draw menu, and I'll switch back to Simulator here, and I can find this indication drop down, click that, and then I can add a circuit breaker. And then I can just click at a position along the line that I want it to be, and if I want to change any of these characteristics, I can do so, and then click OK. And you can see that it also added these other circuit breakers automatically when I inserted the transmission line. And there's also a single circuit breaker on the generator and then one on the load. And again, these are just indicators to the user to let you know the status of the line. At this point, I'm going to go ahead and save my case again. And the Save Case button is also on the Quick Access toolbar. So if you want, you can just click on that. I can also add some descriptive background text from the Draw menu. Under Background, I can click Text, and this allows you to put in just basically any text that you want on the one line. You can click the position that you want the text to be and then type in the text, such as we could write in first case and then click OK, and it'll place it on the one-line diagram. I can then go in and change the size, for example, by clicking and dragging on the handles. Like the buses and the other objects, I can click and drag to relocate it. I can also change its characteristics, such as the font and the color and so forth, with several of these options in the formatting group, ribbon group. So if I've got some text or another object selected, I could, for example, click on the font button. For example, I could change the font by clicking in the box down here. I could start to type in Times, and I could select that. I could make it bold or change the color and do other common text attributes, and then click OK. Other things that you can do are change like the line and the fill for things that have those characteristics. I think for text it'll just provide a background, a border line. And a lot of these options actually are accessed through the same dialog. They just are shown on different tabs. So for example, in the Format dialog that comes up when I click on those buttons up there, I can switch between the different options that are related to the formatting. So I'll click on OK to close that. Besides just background text, you can also add fields that pertain to certain objects like generators or buses. If I click the field drop down on this draw ribbon, and then for example the bus field, and then I'll bring the mouse down near a bus of interest, let's say bus 2, and I'll just click where I want the field to appear. And it will bring up a field dialog, and I can select on here several different attributes of the field. Like for example, how many digits to put in the field, how many digits to put to the right of the decimal, and so on. Several common fields will appear with their own buttons right here, but if you want to use a field that does not appear with its own button, you can select the button right here that says to select a field, and then you can click on the Find Field, and it will give you a list of all the fields that pertain to that particular object type. As you can see, there's quite a few. So I can expand this list if I want to see everything, or collapse it just to see them in groups. And I'm just going to go ahead and cancel out of this, and I'm going to use the bus voltage to show. This will be the per unit voltage magnitude. And then I'll click OK, and then it'll be shown on the one-line diagram. So I could also go ahead and add another bus field, for example, for the angle. And I can select that from one of the commonly used fields as well. And then I can move them around so that they appear and are readable. And let's say I can also go in and put a transmission line field in. For example, the megawatts that are flowing down the line. And transmission line fields generally could be sensitive to which end of the line that you specify because of losses in the line. So I'm going to go ahead and add the megawatts on the line, and I'm going to do it at both ends as well. So if I click towards the bus 1 end of the line, it'll show bus 1 is the near bus, bus 2 is the far bus. And I'll go ahead and use megawatt flow, click OK, and then repeat the same procedure for the other end of the line. And you can see this time now it identifies bus 2 as the near end and 1 as the far end because I clicked on the other end of the line. At this point, let's go ahead and solve our power flow case. And looking back on the slides, we can see here that in order to solve the case, we must be in run mode. To put all the objects on the one-line diagram and to edit the one-line diagram and the case as well, we had to be in edit mode. So we will switch to run mode, and it will only allow you to do so if there are no errors in the case that you've defined. So back in Simulator, I can go up here to the mode section of this draw ribbon, and this appears on several of the other ribbons as well. And I'll switch to run, and if I open my log, I can see too that it performed some validation when I switched into run mode. And it has some information here about the voltage at bus 2. Of course, when I solve the case, it's going to come up with some new values there as well. So I'm going to go ahead and go up to my quick access toolbar up here, and if I float over this icon right here, it says single solution. Basically what that's going to do is solve the power flow. And my log will tell me right here too adjustments that have been made in order to get the power flow to converge. So I've got my slack bus and my generator that's regulating voltage at the slack bus, and then I've got a load at bus 2 and a transmission line that separates them, and it solves for the flow on the line and the system state, basically being the bus magnitude and angle at each bus in the system. So I'm going to close my log here just to get that out of the way. Another thing I can do is actually animate the simulation. I can see that it shows arrows right here for the power flowing down the line and other graphical aids such as that. If I click on the Tools menu, there's a play button on this Power Flow Tools section of the ribbon, and if I click the play button, it will actually animate the flows then on the system, and I can see the power flowing through the simple network from the generator across the transmission line and to the load. And to stop that, I can just click the stop button in the same position. You can also change the appearance of the arrows that are used to animate the power flows as well, and a couple other related options. If we click on the Options tab, from here we can go to our one-line display options, and there's actually also on the Options tab, the Options ribbon rather, there are a bunch of different options that also appear in other ribbons as well, but they're kind of all concentrated here for ease of use too. If you know you're looking for an option of some sort, but you're not sure exactly what menu or what ribbon it might be under, you can also always find it under the Options ribbon. So if I open my one-line display options, and then select Animated Flows, I can change things like the color that's used in the flow, and I can tell it, for example, to show megavars as well. For example, I can tell it to show the actual megawatt and megavar power flow. And if I resize this a little bit and then tell it to just apply those settings, then I can see I get some blue arrows in there for the VARs that are flowing down the line as well. You can also change the size references and things like that. And probably the easiest way to use this, and what I use most commonly, is to first select this button that says to set the size, density, and reference values based on this one line. It'll basically set these parameters into values that seem to make sense for that one line. You can change the size of the arrows and the density, how many arrows are shown per unit length on the line, and so forth. Here, reference values basically refer to what value of flow corresponds to the size that's shown, and so forth. And really the best way to see how to do this is to kind of tell it to automatically set them, and then if you want to come back in here and adjust some of the settings, you can. But for now I'll just go ahead and click OK, and I can see that it resized them so that they're a little bit bigger. Makes them a little bit easier to see on this one line. So actually I'm going to go back in and take the VAR settings off. That should make it a little bit easier to look at for this small case right here. So I'll just tell it to show only the actual megawatt power flow, and then click OK. So the next thing we're going to do is add another bus to the system, give it its own load and another generator and a couple more transmission lines. And in this way we can kind of see how Simulator can recalculate values if we open one of the transmission lines, for example, or drop one of the loads, drop one of the generators, and so forth. So back in Simulator, first I'll switch to the edit mode so that I can add buses and transmission lines and other things to the case. And then I'll go back to the draw menu, and again, to add another bus, I'll click on network and then bus, and then in my one line diagram I can just click where I want to add that bus, and I'll take the number 3 and add in the text 3 for the bus name, and then click OK. It'll insert it, and I'm just going to pan a little bit with the arrows and zoom out a little bit by holding down the control key and then the down arrows, if you recall from the shortcuts that we saw earlier, just so that I can see a little bit better on this one line diagram. And then I'll go to the load, or to the network, and then add a load to bus 3. And I want to give it a value of, let's say, 400 megawatts constant power and 200 megavars. And as far as the orientation on the display, I'll just select down so that it's pointing down, and everything else I'll accept the defaults. Also, if you don't like things like the orientation, it's very easy to change. You can just simply click on the load, and then when its handles appear, you can float the mouse over like a vertex, click and drag, and so forth to stretch it. That's very easy to do with the loads. And I'm going to resize this bus by clicking on it and making it a little bit bigger. You can also do that in the menu, but sometimes it's easier to do that graphically. And then I'll add another generator to the bus 3. And I'll give it an output of, let's say, 300 megawatts. And I'll leave all the defaults as they are. And then click OK. And then I'm going to add a couple more transmission lines to connect bus 3 to the others. So I'll start, click on 1, add a couple of vertices here, and then when I'm ready to terminate it on 3, I'll double click on 3. And I'm going to give it the same parameters that I used before. 0.02 per unit for the resistance, 0.08 for the reactance, and 0.1 for the shunt charging. And I'll give it a limit of 400. When I'm done, I'll click OK. And do the same thing again to connect bus 2 to bus 3. And again, I'll give it the same parameters. 0.02, 0.08, 0.1, and a limit of 400. And I can go in and reroute things. Maybe move some text around if need be to clean it up. So the next thing I want to do is give the control area a particular method for controlling generation and dispatching generation. And to do that, I'll click on the case information ribbon and then click on network, or rather aggregation, and then areas. And basically this is going to launch the Model Explorer, which we'll talk a little bit more about in a later section. But for now, we're looking at areas in this display, and I want to click on this AGC status cell for Area 1, which is the only area that we have in the case. And I just want to double click it once, so it switches it to Part AGC. That stands for Participation Factor Control. AGC, and we'll talk more about that later. For now, we can just close the window and then switch to run mode. And then I can go to my tools, and in the PowerFlow Tools ribbon group, I can select the single solution full Newton, and it'll basically then redispatch the generation and show the flows on the transmission lines as well. I can also animate it like we did before, and I can interact with this diagram. For example, I can open the transmission line between 2 and 3. It will automatically resolve the power flow and show how the new flows redistribute. Things like the voltage and the angle and the fields that I have on here are shown as well. I could open the load at bus 3 and again it will show how the flows redistribute. And I can stop the animation when I'm done experimenting with that. And switching back over to the slides, some of the characteristics of the one-line diagram are shown on here as well. The slack bus is identified with the text slack inside its rotor. Generator rotors will generally be displayed to represent their rotor angle. Pie charts will show the percentage of flow that's being carried on that line as a share of the total MVA rating. Recall in our case we set all of the transmission lines to have a rating of 400. So the part of the pie chart that's shaded is basically the share of 400 that each line is carrying. And of course you can click on the circuit breakers as well to change their status. And similar to the circuit breakers, we can also insert additional pie charts. They're generally automatically inserted on transmission lines that have non-zero MVA limits to them. But if you'd like to select or insert rather additional pie charts, you can do that from the draw menu in a similar way to what we did with the transmission line or with the circuit breakers. So there's also help that's available within PowerWorld Simulator, and it's generally context sensitive. So in the one-line diagram you can roll your cursor over one of the objects and then press the F1 key. And if I switch back to Simulator, I can show that. For example, I'll go over the generator, and then if I press F1 it will launch the PowerWorld Simulator help, and it'll jump to the generator information in the help. And of course the help is it's got context or contents. It also has index terms that you can type in. So if I start to type in generator, it will jump to that, and I can see specific topics related to generators. And then if I just want to search for certain terms, I can do that as well. So I can search for generator and then tell it to list the topics, and it'll list a bunch of different topics. Of course the generator occurs quite frequently throughout, but if you put in something more specific you should get a narrower list of topics that are shown here. So I'll go ahead and close my help. And generally you can use the F1 key to bring up context sensitive help in other areas besides just the one-line diagram. If you've got a dialog open or a case information display, the Model Explorer open, we'll talk more about that later, then you can generally bring up context sensitive help. So basically we talked a little bit about formatting objects like the text and things like that. You can also set up what's called default drawing values, which will affect how future things that you add to the one-line diagram will be displayed. So if you want to standardize, for example, the fields that show up around a bus, like the per unit voltage magnitude and the angle, then you can go into the default drawing values and basically tell it to always insert those fields every time you insert a bus. So I'll switch back over to Simulator and then click on One Lines and then the default drawing values. And here I can see I've got different object types shown on the left, and then the details kind of shown on the right. So from here, for example, if I select bus, it'll show me a bunch of different values, and for a lot of objects you can have them show different characteristics depending on the voltage level or the nominal kV level of the object. So by default here it's showing that buses of greater nominal kV are shown larger, and I can change those numbers if I want to. One of the features that we have as well down here is you can have it jump to a certain set of presets for say single kV or multiple level, which is what's shown right here, defaults. And if you click those, it'll bring up a dialog which asks, do you really want to switch? And if you say yes, then it'll populate them. Of course, that's what we started with right there. If I go to the transmission lines, I can see that for different nominal kV levels, it also will draw the line in different colors as well. And what we've been doing has all been between 100 and 200 kV, so it's been drawing the lines as black, which is in line with what's shown here. But if I go back to the bus screen, if I select it on the left, then for example I could go to this other tab over here. We've got the characteristics of the buses itself, again, the colors and the size and so forth. And then there's also a tab for most of these objects for the field positions as well. So if I click on that, I can change or add different fields to automatically be displayed with the bus when I add the bus. And it basically has 8 different placeholders around the bus, and the bus is shown in the vertical orientation and in the horizontal orientation, and basically what those position placeholders mean for the different orientations. Right now it's set to show the bus's name in this position right here, immediately to the right of the bus for a horizontal orientation, and in this position right here for a vertical orientation. Let's say I wanted to add the bus's voltage magnitude and angle to the set of defaults. I could pick a position here, let's say this position 1, and click it, and then select, for example, the bus voltage for that position. Click OK. And it'll ask if I really want to do that for all voltage levels, and I will say yes. And then on position 2, I'll select the bus angle in degrees, and then click OK, and I'll say yes to that as well. So now it's showing that these fields will appear here. And of course there's all kinds of different characteristics that I can change for these different object types. I can change which fields are shown for generators. If I go back from the field positions to just the generator, again I can change its default size and so forth. I'll go ahead and click close, and then just to give you an illustration of what it would do, I'm going to switch to the edit mode, back to the edit mode, and then to the draw ribbon, and again as if I'm going to insert another bus from the network drop down, I'll click bus, and I'm just going to select all the defaults right here. We'll call it bus 4, then click OK, and it added the additional fields that I specified in those default drawing values. It'll basically apply those for any new object I create. If I want to go back to my old objects that I already have on the display, I could select them as well, and I could right click on the selected object, and one of the handy options available on the local menu that comes up when you right click is you can tell it that I want to apply the default draw values to that bus. So this bus was originally inserted in the diagram before I changed the default drawing values. Now that I've changed them, I want to go ahead and apply that to the bus, and I'll click OK. It brings up another dialog which asks specifically what do you want to apply from the defaults to this object. Now I'm going to change this. I'm going to tell it not to apply the size because I did stretch this earlier, and maybe I don't want it to stretch back. So I'll click OK. So switching back to the slides, we can see here that the default drawing values apply to the future objects that you're going to add. And here's some screenshots for the transmission line that we saw earlier. And then here's a shot for the fields that it automatically shows around the transmission lines and the positions at which those are shown. And what if we want to format objects that we've already added to the display. Again, the default drawing values apply to the future ones. If we want to change the format of objects that are already on display, then we can take a couple shortcuts. We can select multiple objects and then format them all in a consistent manner. We can add fields to multiple objects and so forth. So there's a couple different ways that we can select more than one object at a time. The simplest is just to individually left click on the objects while holding down the shift key. So if I switch over to simulator, I can illustrate this. I've got to be in edit mode, of course, to select the objects, but I can hold down the shift key and pick multiple buses, for example. And then I could right click on one of those buses and then bring up the option to format the selection. And then I can change things like the thickness, the color, and so forth. So if I change the thickness to 2, for example, and then click OK, it'll make all of the buses then thicker that I selected. Another option is in this draw menu. There's this select region, and you can basically change the region from a rectangle to a polygon to an ellipse, rectangle being generally the simplest. And if I click this select region, then I get a cursor that I can click and drag on the one-line diagram, and when I release it, it will then select all the objects that I selected with that region. Another option that's available besides the shape of the region is there's a toggle right here for picking things that are entirely inside the region that you selected or things that are just touching. That's pretty self-explanatory. Inside means that basically the whole object must be inside your region, and touching just means that any part of the object must be touching some part of your select region, and then it will select it. And then finally, the third option is this select by criteria. I'm going to go ahead and click in the background here of my one line, just a single click with the left mouse button, and then I'll change to the select by criteria. And basically what this allows you to do is select what types of objects that you want it to select. For example, I could pick all of the buses in the system, and I'll just do that. You could specify certain area numbers only, certain zone numbers, certain voltage levels, certain screen layers, etc. I'm just going to tell it basically to select every bus on the display, and then I'll click OK. And then when it's done, you can see the handles have appeared on every single bus. So the slide here also describes the select by criteria dialog and several of the options that are available on it. So with certain items on the select by criteria dialog, you might have additional options. For example, for bus fields, if you check that box, then it gives you some specific things that you can pick from. And then when you do that, you can specify only certain fields. For example, just the name and the number of the bus field. And then by selecting different tabs on that dialog, for example, areas, zones, or screen layers, you can specify just certain areas, zones, and screen layers accordingly that you want to select those objects on. And then you can also use an advanced filter in the select by criteria dialog to be even more specific than you can with, for example, the areas, zones, and layers. And to demonstrate that, I'll actually switch back to simulator here and reopen the select by criteria dialog. And then, for example, on the buses, say I only wanted to select buses that had generation connected to them in excess of 100 megawatts. I could double click on the filter space and bring up the advanced filters. And I don't have any filters shown or created to this point for buses, so I'm creating one as I go right now. And to use this, I'll go down here and select a condition. And for example, if I start typing in the word generator, generators megawatt. The next space over, the next drop down is basically a comparator, and I'm just going to leave it at its default greater than, but if you want to change it to something else, you can see a bunch of options by clicking on the drop down. And then I have to put in a value to compare it to. So I could put in, for example, 100, which would then specify buses that had generation connected to it greater than 100 megawatts. So then I'll click filter, and it'll prompt me for a name, and I'll just type in a very descriptive string here, say gen greater than 100, and then click OK. And then I'll come back to this our original select by criteria dialog, and I'll see that it's placed this filter in this space right here. So if I say OK, select by this criteria, it will select only buses 1 and 3, which have generation connected to them that exceeds 100. So bus 2 and bus 4 are in this way not selected. So then after you've made a selection, a multiple selection or a single object selection, you can go again to the formatting ribbon group, or you can right click on the selection and bring up a local menu and choose format selection. And again, these are some of the things that we looked at to this point. You can change the line fill for certain objects, levels, layers, the display size, and so forth. So the next thing we'll talk about here is screen layers. And screen layers are pretty useful because you can add certain objects to different layers, and then you can at a later point go in and turn certain layers on and off, which is pretty handy. So for example, you could assign everything in your case that's at 500 kV and above to a particular screen layer, and then maybe something that's at a different voltage level to another screen layer. And then turning these objects on and off is as easy as toggling the screen layer from on to off. So we do that from the one line ribbon tab and then select layers. So if I switch back over to simulator and I choose my one line ribbon tab, then I can see that there's a layers button right here. So if I click it and then choose define layers, it'll bring up this screen layers information display rather, and I've got nothing created to this point except for the default layer. That of course is always going to be in there by default, and it's grayed out because I can't change any of these attributes associated with the default layer. Of course, if I create a layer of my own, then I can change its attributes. So to create one, I right click in the grid, just somewhere on this grid, and then choose insert. And then from there I can give it a name. So for example, maybe I'll give the layer a name and I'll call it buses. The name is just a name. I have to actually go in and assign buses to that layer if in fact that's what I intend to do. It's not going to automatically assign buses just because of the name that I give it. So you can also have a conditional level, and this is a zoom level in percentage at which the objects on that layer are displayed or not displayed. By default it runs the entire range from 0 to 9900, but if you want you could change that and then objects that are on that screen layer will only appear when the zoom level is between those numbers specified. Recall we looked at the zoom level a little bit earlier in this dialog right here. It can be set to a certain percentage, and those percentages are what these numbers correspond to. So I'm just going to choose the defaults here and then click OK. Now I've got a new screen layer and I can toggle it on and off. Of course, the next thing I need to do is actually assign objects to it. So I'm going to go ahead and close this box for now. I've got these two other buses already in my selection set. If I want, I can hold down the shift key, for example, and then maybe pick up another bus of interest and then go to the draw menu, and then I have the option for changing. Again, I can go to these formatting things right here and click on the level/layers, and then when I bring this up, I can change the layer to buses, for example. I could click OK, and then once I've created a screen layer, I can go back to actually the layers are shown here as well. It's repeated in a couple different places where it's convenient. On the formatting tab right here, I can click that arrow or that button that shows the layers. The drop down arrow indicates that there's an additional thing that'll show up if you click it, and I could just basically decheck the buses layer, and if I do that, it basically it hides everything that's on that layer. So I've in fact turned that layer off. I can check it again to turn it back on. And another way I can affect that is if I go into my define layers and then bring this back up. Again, I can indicate whether or not I want that layer to be shown, whether or not I want the objects on that layer to be selectable in edit mode. That's kind of handy if you've got a layer that's basically designed to hold background objects or borders or things like that that you don't want to actually move. You could toggle that to no, and that way you won't be able to accidentally select them when you're in edit mode, if you don't want to be able to accidentally select them. And I can also access information on screen layers if I right click anywhere, not on a specific object, but rather on just a blank part of the background in the one-line diagram. I can bring up this local menu option for showing the layers, and I can see I've got the default layer, which is grayed out because I can't change its characteristics, or the buses one. And those are basically shown on the slide here as well, where these different views. This is the formatting ribbon group on the draw menu, and then the screen layers information here, and then this is what shows up if you right click in the background on the one line itself. So another thing that we have is display levels, and objects that are on the one line, as they're created, they basically take on one of four different stack levels. These are referred to as base, background, middle, and top. And different types of object levels are basically assigned to those different stack levels. For example, the transmission lines are shown on the middle level, while the circuit breakers are on the top level. In this way, the circuit breakers are always drawn on top of the transmission line, and you don't have the transmission line graphically. If I switch back to simulator right here, I don't see the line being drawn through the circuit breaker. So that pretty much makes sense. Same thing with the pie charts. If you want, though, you can change those levels. If I select an object, for example, like this transmission line, and I go back into levels layers, I'll see that it has a stack level of middle, and I could change that if I wanted to top, middle, background, base, etc. I'm going to hit cancel. And then another thing you can do in this formatting menu is you can send objects to the back or bring them to the front. Just by making a selection and then clicking on those buttons. And what this will do, if I switch back to my slides, is basically it will change its level relative to other objects that are on the same stack level. So here's the stack level and the layer, again in that levels layer dialog. And then the bring to front and the send to back, again, it operates on objects that are within the same stack level. So how it's drawn, or what's shown on top, is first governed by the stack level. And then objects that have the same stack level can be manipulated relative to one another using the bring to front and the send to back. And again, for objects that you've created, you can go in and change their display and size parameters, or their font parameters as well. And for fields, you can change specific information related to the field. Things like how it's displayed. We talked earlier when we were creating fields about the digits and the digits to the right of the decimal place. And I'll just flip over to Simulator to show an example of that. So for example, if I select this bus field right here, and then I go into the fields formatting, I could change actually the field that it points to as well, and I could change its characteristics, such as how many decimals to show. And then that's been changed accordingly. And so other things that can be done, this slide just gives you some examples. You can open the B7 flat case and its one-line diagram, and can go through and, for example, try some of these things with select by criteria. The B7 flat case is one that does ship with Simulator, so you should be able to find it in the sample cases directory under your Simulator directory. And again, we can apply the default drawing values to a selection. If you selected multiple objects and you've gone in and you've changed the default drawing values, you can right-click, again, just recall, on the object, for example, this bus right here, and then I can tell it to apply the default drawing values to the bus. I can choose which attributes from the default drawing values that I wish to apply, and then click OK. In this case, it changed the thickness back to the original value. Recall that earlier I had changed the thickness of several of these buses in an earlier selection. This way it's just restored the defaults. And other types of objects that can be added to the one-line diagram are things like links to other one-line diagrams, or links to other documents. And these can be documents that are on the local computer. They can be web addresses, whatever you like. So basically, if we go back to the Draw Ribbon tab, and a couple of the other objects that are available under the background, we could put in, we talked about text a little bit earlier. Memo text allows you to basically just put in a box and have text that wraps inside that box. The one-line link, if I choose that, I can then click in the one-line diagram where I want that link to be, and then I can browse on my network for another one-line diagram. And once I find it, I can select it. I'm just going to hit cancel right here. But basically, it will then insert a link which I can click from this one line to automatically open another one line. And I'll just go ahead and hit cancel. And then I could also put in a document link if I wanted to link to, say, a Word document, a PowerPoint document, or to some location on the web. I can hit browse here, pick any file that I want, or I can enter a URL like an HTTP address, and so forth. And if it's an executable file, it can have some parameters that you can associate with it, and so on. And I'll just hit cancel. And then you can also add background pictures like JPEGs, things like that. Again, that's also in the same place in the draw ribbon, the background picture, and I could select like a JPEG or a bitmap. These are the different graphic types that are supported, and then once I put it in there, I can stretch it or change its formatting as well. So you can also use the Windows clipboard to copy objects and then paste them into the one-line diagram. So here's just an example with some bitmaps and graphic objects that are shown on a one-line diagram. So that concludes this topic. Thank you for joining us, and certainly if you have any questions related to this or anything else in PowerWorld Simulator, please feel free to give us a call at 217-384-6330.